In substitution, your task is going to be to implement a substitution cipher, where you'll encrypt or encipher some plaintext by taking every alphabetic character in that plaintext and replacing it with another character. What might that actually look like? Well, let's take a look at a sample key. Here we have the plaintext letters of the alphabet from A all the way through Z, and in a substitution cipher, we're going to replace each of those plaintext characters with a ciphertext character. For example, here is a mapping that maps the plaintext character A to the letter J, maps the letter B to T, maps the letter C to R, so on and so forth. How do we actually use this inside of a cipher? Well, if the plaintext is the word hello, then using this substitution cipher, we would end up with the ciphertext VKXXN, because H in plaintext maps to V in the ciphertext, E maps to K, both of the L's map to the letter X, and of course O maps to the letter N, which gives us that resulting ciphertext. Your task is going to be to write a program in C that is going to implement such a substitution cipher. How does the program work? Well, you'll run the program by calling /substitution, followed by a 26-character long key that's going to describe how you're going to map each of the alphabetic characters into other alphabetic characters, where here the first character is what we map A to, the second character is what we map B to, so on and so forth. Your program should then prompt the user to type in some plaintext, and if the user types in ABC, for example, then your program should output ciphertext followed by the enciphered version of that plaintext, in this case J, T, and then R. So if we were to call that same substitution cipher, passing in hello as the plaintext, then the output is VKXXN. Of course, your program should be able to support plaintext that isn't just uppercase characters. So if we were to instead call /substitution followed by the same key, and the plaintext were hello in all lowercase letters, then the output should still be VKXXN, but the characters should be lowercase. The case of the plaintext should be preserved. And if our plaintext was a little more complicated, for example, if we called /substitution on the same key, but this time the plaintext were this is CS50, then this is what the ciphertext would look like. Notice in particular that the characters that were originally uppercase in the plaintext are still uppercase in the ciphertext, and the characters that were originally lowercase in the plaintext are still lowercase in the ciphertext. Any character that isn't a letter, like the space or the digits or the punctuation, those haven't been changed at all, and they're the same in both the plaintext and the ciphertext. In addition, the key that your program takes as a command line argument should be case insensitive. Here, for example, the key is all uppercase letters, but the program should behave exactly the same if, for example, the key were all lowercase letters, or if there was a mix of uppercase and lowercase letters inside of the key. However, not every key that's provided as a command line argument is necessarily going to be a valid substitution cipher. So there's some additional work you'll need to do in order to validate the key, to make sure it is indeed valid. For example, if a user were to call /substitution but not provide a key at all, then your program should remind the user of how to use the program by calling /substitution followed by a key. What else might count as an invalid key? Well, if a user were to call /substitution and provide a key that's fewer than 26 characters, then we're not going to know how to map every single alphabetic character to another character. So in this case, your program, rather than prompting the user to type in any plaintext, should instead report that the key must contain 26 characters and then return with a status code of 1 to indicate an error. What else might be considered an invalid key? Well, if the user were to run /substitution and then provide this key, which is 26 characters, but the last character is the number 2 instead of an alphabetic character, this key is not valid, because in a valid substitution cipher, every letter should be substituted for another letter. So if any character in the key that's provided as a command line argument is not an alphabetic character, then your program should report that error, reporting to the user that the key must only contain alphabetic characters, and then returning 1, for example, to indicate that there was in fact an error. And finally, if the user were to run /substitution and then provide this key, where notice that the first character of the key is the letter J, and the last character of the key is also the letter J, this too is not a valid substitution. And your program should report to the user that the key should not contain repeated characters, and your program should again exit with a return code of 1. So in summary, what do you need to do in this problem? Well, you'll first need to get the key, Then you'll need to validate the key to make sure that it's a valid substitution. Then you'll need to prompt the user to type in some plain text. Then you'll need to encipher that plain text using your substitution key. And then finally, you'll need to print out that ciphertext. How are you going to get the key? Well, recall that the key is going to be provided as a command line argument. The user is going to run your program by running /substitution followed by the key. How do you extract that command line argument? Well, you can structure your main function as something like this, taking two arguments, one of which is an int argc, representing the number of command line arguments, and one of which is an array of strings, argv, representing all of the command line arguments that were provided. Once you've collected the command line arguments, the next step is going to be validating the key to make sure that it's valid. And here, you should check the key length to make sure that it is in fact 26 characters. You should also check to make sure that there are no non-alphabetic characters inside of the key. And you should also check for repeated characters, because every letter of the alphabet should appear once and only once in the key, regardless of whether it's uppercase or lowercase. After you've validated the key, then you can start to prompt the user to type in some input by asking for plain text. Here, you can use the function getString, declared in the CS50 library, as a way of getting input from the user as a string. After you've gotten the string, then you can encipher the text, where for each alphabetic character, you'll need to determine, based on the substitution cipher that you've collected as a command line argument input, what character should this alphabetic character map to, making sure to preserve case, so that uppercase characters stay uppercase and lowercase characters stay lowercase. If there are any non-alphabetic characters, like spaces or punctuation or numbers, those characters should be left as is and unchanged between the plain text and the ciphertext. Finally, after all of that, you should be able to print out the ciphertext to the user so that they see the enciphered version of their original message. You can test your code by running /substitution followed by a valid 26-character substitution key, then typing in some plain text and making sure the ciphertext is the result of substituting all of the alphabetic characters for the characters that are mapped to by the key. My name is Brian, and this was Substitution.